Everybody, welcome to the 83rd episode of the How Do You Know show. I'm Dr. Daniel Barth, and today we have our guest today, Chris Vollmer, who is a local astronomer, and he's a fan of the How Do You Know program and of the Explore Scientific experience. And we asked him to come on the show today because we always like to have conversation, not just myself talking, but conversations with other astronomers and people who are interested in astronomy and space exploration. Today's show, of course, is brought to you by Explore Scientific, and we hope that you'll be checking out our certified pre-owned program. The Explore folks have been busy going through and preparing CPO items. They're guaranteed to be optically perfect. They may have slight cosmetic defects on them, but impressive savings. And for those of you shopping for the holidays for someone, well, a chance to pick up a real bargain. And any real astronomer can tell you, when you take your equipment out in the dark at night, it's going to get a scuff or two pretty quick anyway. So this is a real chance for you to save this Christmas. We also are brought to you by the Star Mentor book. And Chris here has got his copy, and he's very excited about it. And it's, well, how would you describe the book, Chris?
Well, it's got a lot of information for any astronomer or freelance astronomer.
Absolutely. It's really designed to help you sit down and learn how to operate your telescope, how to read a star map, and how to explore the sky. Because I've always believed, as an astronomy educator, the more knowledge you bring to the eyepiece, the more value you take away. And it makes astronomy a lifelong hobby rather than, oh, well, I got that for Christmas and now it's in the garage. Because we don't want that. We want you to stay. So we're going to jump right into the show today. And our title for this episode is When Worlds Collide. Now, if you're an old character like me, you may remember having seen the 1951 classic, not the remake. I don't like remakes. The classic George Pal, When Worlds Collide, directed by Rudolph Maté. Now, this, people didn't really receive it very well when it was first released, Chris, because although it did win an Academy Award for special effects, people were like, oh, well, it's scientifically flawed. George Pal, wherever you are today, my friend, hopefully looking down on us, a lot of your ideas have been vindicated. And when we take a look at this, we have to kind of go back. What we're talking about today is literally planets in collision. And during my lifetime, this idea was complete nonsense, according to a wide body of world experts. And we have to go back, this whole collision idea. In the 20th century, the idea that meteors and asteroids, okay, let's go ahead and here we go. I'm going to help you out. We're going to mic you up, my friend, and just put that in your lap. It'll be fine. Okay. During the 20th century, people thought meteors don't hit the Earth. They all burn up. That's what shooting stars are. Because if they did, we'd see a lot more craters. What about the moon? I was taught in school, almost all the craters on the moon are volcanic. It wasn't true. We go a little bit farther back, and some of you may have been out in the Southwest and visited the very famous Barringer crater. It's in Arizona. It's about 1 kilometer wide and about 300 or 400 meters deep. It is truly an impressive sight. And this was owned and marketed by Daniel Barringer, and his great idea was that this was a meteor crater, and he figured, well, if a meteor slammed into it, it would have had to have been dense and made of iron, and he estimated that there would be 10 million tons of iron buried somewhere under the crater. He bought the land in, I think it was 1902, and pretty much bankrupted himself. He was a mining entrepreneur. He went back and studied geology and got a geology degree. When he went broke trying to mine for iron that wasn't there, It turns out this huge meteor was completely vaporized on impact, if you can imagine that.
Oh, wow.
The Barringer crater, which is a kilometer wide and half a kilometer deep, that thing was excavated in 2 seconds. All that rock, the rock on the surface was literally folded back. And when something like this comes in from a high angle, it's like a water balloon on concrete. Most of the energy goes out radially. Everything within 50 miles would have died from the heat pulse and the blast wave and tons of rock and debris going out at supersonic speeds. It would have been a very bad place to be. This impact occurred about 50,000 years ago, and Barringer was sure it was a meteor crater. When he went broke trying to mine it, like P.T. Barnum, he decided to turn lemons into lemonade, and he decided, hey, you know what? I'm going to go ahead and market this as an attraction. Come see the world-famous meteor crater. And he went and studied geology for a while, and then he came back and he said, I've proved it. Well, his word wasn't well accepted. Can you imagine that? Somebody trying to market this attraction saying, I've got proof, I did it myself.
Wow.
Yeah, oh, wow is right. There was a lot of skepticism from the scientific community. And the scientific community at the time said, oh, no. This was either a volcanic event or a steam explosion. I don't know how you get a steam explosion a kilometer wide, but there it was. Anyway, Barringer believed until his death, he firmly claimed until his death that this was a meteor crater indeed, and he passed away in 1929. His family still owns Barringer Crater and the surrounding land to this day, and they have excavated some substantive meteor fragments, some of them quite large, but nothing like the 10 million tons the original Mr. Barringer hoped to find. You know, nobody actually proved this was a meteoric crater until 1961. And it was Gene Shoemaker, the astronomer who is probably familiar to a lot of you, Comet Shoemaker-Levy 9. Shoemaker wanted to be an astronaut, and he was a geologist, and he approached NASA and he says, you're sending people to a ball of rock. Shouldn't you send a geologist? Unfortunately, he had Addison's disease, a problem with his heart, and he could not go, but he trained all the Apollo crews in geology, and he was a mentor to Harrison Schmitt, the only actual geologist we sent up there. But he went to Meteor Crater, and in 1961, he founded in Flagstaff the first institute for exploring meteoric impacts on Earth and beyond. And he brought back proof. Dr. Shoemaker found rock folding, because it's kind of amazing. When you apply enough heat and pressure, rocks are plastic.
Oh, I didn't know that.
It's kind of stunning, and you can go to Meteor Crater yourself, and you can see places where the granite layers have literally, and sandstone layers have been folded over, like somebody making half a sandwich and just folding it over. He also find, yes, sir.
We grow rocks here. It's the state crop.
Indeed, I would say that's right. Barthland Ranch up in the Ozarks, our soil is about an inch deep, and after that, you hit the rocks. It's not a great farm. It was a lovely ranch. But he found tektite glass, basically sand that had been fused into balls of glass, and they formed perfect spherules, and they rained down over the area. He also found shocked quartz grains, which require 50,000 pounds of pressure and extreme heat of thousands of degrees. So this is obviously something that, if indeed anyone was living there in the area 50,000 years ago, I don't think it was inhabited, but they would not have had any kind of technology to produce that. And Dr. Shoemaker showed that indeed Meteor Crater was an impact crater, and it was the first confirmed impact crater on the Earth. And so we went with this, and it was a great discovery. It was a great day for science. And people looked at the moon in 1961, NASA had been founded. In 58, people were looking towards the moon. America and the Soviet Union were in the space race. And the question of, what is it? Why does it look the way it is? What are the dark spots made of? What about the craters? There's so many. How did they occur? I was taught in school that all of these craters, or almost all of them, were volcanic. There might be one or two meteor craters, but the moon was a really volcanic place, which, yes and no. But indeed, my science textbooks were all wrong. Were all wrong in the early 60s.
Wow.
So
Okay.
this basically leads us to an interesting side note. Before Apollo went to the moon, do you know there were 3 theories on how the moon was formed? Have you ever heard of these?
No.
No, I haven't heard of these? Okay. Well, the first one, and the one that was highly favored, was called co-formation. The idea was there was a large ball of gas and dust and rock particles that condensed, and actually it didn't condense into one body, but like a double yolk egg, it condensed into 2 separate bodies, one orbiting the other. And so, according to this theory, the Earth and Moon's composition should be essentially identical. Same source, same ingredients. It's like Betty Crocker box cake. It comes out the same every time, right? Whether you make small cupcakes or a big sheet cake, all taste the same. And so the co-formation people expected Apollo to come back and say, it's just like the crust of the Earth. The other theory, and the one that I really liked because it had a really cool illustration in my science textbook, was called fission theory. The idea was early Earth was spinning really, really fast. Have you ever seen one of these videos where someone overspins a grinding disc and it explodes? Yeah, a lot of us have seen that kind of YouTube stuff. That's basically what they thought. Well, it was spinning really, really fast, and a chunk of the Earth's crust tore off, was flung out, and became the moon. Well, what happened to the scar from all this missing crust? It became the Pacific Ocean basin. And if you look at the
Amazing.
volume, it's sheet of the envelope calculation. It's could be.
That's amazing.
Well, if that idea was right, then indeed the Apollo people would find that the moon was made of stuff that looked very much like seafloor crust.
Okay.
And the third theory was called capture theory. And this one was kind of considered a little bit wild. Capture theory, the moon was made somewhere else, out in the outer solar system. It got ejected from Jupiter or Saturn somewhere, and it fell in and it got captured by the Earth's gravity. And they said, well, the moon's only about 1% the mass of the Earth. Maybe it could happen. And these people expected the moon wouldn't look anything like the Earth, made somewhere else, different place, different time. They didn't expect the age to be the same. Well, none of these theories panned out. And it's exactly what everyone said. People were really disappointed. But there was a fourth theory waiting in the wings. And the people who liked it were kind of like, nobody paid any attention to them. They were considered kind of nutty. The fourth theory was called the Big Impact theory. What if a great big planet, the size of Mars, half the size of Earth, smashed into the early Earth? It would have essentially merged with the Earth, but a lot of the surface material from both worlds would have been ejected, and then gravitationally it would have coalesced into our moon today. And there are many lines of evidence for this. And if you are fans of the How Do You Know program, or if you go to YouTube and you search for How Do You Know episode 16, The Origin of the Moon, and if you download today's show notes, there's a link for you, and you can go right to it. We did a whole program on this and on the evidence and how do we know that the moon was formed by a giant impact? And so this giant impact theory, which is coming out in the mid-70s, because it took a while for them to digest all the Apollo evidence.
Okay.
This wasn't like we're going to throw that theory out. Science doesn't work that way. Fans of our program know this. It's the wheels of science grind slow but sure. And in fact, it took 10, 15 years for the other theories to be rejected and for people to start actually seriously considering big impact. We've done a lot more space exploration since 1969. And we see a lot of evidence for big impacts around the solar system. There's the Hellas Basin on Mars. Excuse me, you take a look at Mars, and what's really strange is that the southern hemisphere, almost planet-wide, is 10 kilometers higher than the north. So if you travel toward, excuse me, maybe it's the other way around. North is 10 kilometers higher. But anyway, you travel across the equator and you have to mount, basically like Mount Everest. You have to mount this huge scarp in order to get into the other hemisphere. And we believe that was a big impact. There's Venus. And why Venus? People say, oh, it spins backwards. But if you look at it the other way, it's really just the axis was tilted 185 degrees.
Okay.
Yeah,
makes
they
sense.
think it took more than one big whack to do Venus. Uranus has a 95-degree tilt. It basically orbits sideways. And so there's lots and lots of evidence, indirect evidence. And lots of people kind of, they bare their teeth and grit their teeth a little bit when we talk about indirect evidence, but can't you know, haven't you seen it? How do you know it really happens? If you haven't actually seen the thing, how can you use this indirect evidence? And so that's always a question. Well, this whole process changed the way we understand how solar systems are built. And today we look at this and we call it accretion theory. And we've seen more evidence of this recently. But accretion theory basically says very small particles stick together because of static charge. And if you build up enough material and it gets to be, 200 to 300 meters to a kilometer wide, then gravity starts to take over. It gets large enough. And we just recently had samples returned from asteroid Bennu. You're familiar with that, right? That made all the news. And it was the OSIRIS-REx lander. We figured Bennu was a rock with some dust and rubble on the top. It's not true. It's not true. It's half a kilometer wide. It's a rubble pile. Have you ever had as a kid, try to climb up on a big pile of sand or pea gravel?
Oh, yeah.
Yeah, right? Your feet sink in and it runs downhill. When asteroid Bennu was touched down by the OSIRIS-REx lander, it was fascinating. They had a probe, and the probe came down, and the idea is that the probe would touch, and then it would give a burst of nitrogen gas. The idea, the very low gravity, this would stir up things, and we would have a little cup here, and we would stir up. We hoped we'd get, 50, maybe if we're really lucky, 200 grams of material. Now you think a can of soda, that's 350 grams. Okay, so one of these little mini cans of soda, that's about, they figured at best. We got a lot more than that, because when the probe hit, the probe moving very, very slowly because the gravity is really low, the probe sunk in almost 2 feet deep, half a meter.
Okay, I remember that.
The mass of the probe sunk all the way into the interior of Bennu, and when they injected their nitrogen gas, they excavated about 6 tons of material with basically an air gun and a compressor.
Oh my goodness.
And the collection chamber was so full they had trouble getting it shut. They worried they weren't going to be able to get a sample back because it wouldn't survive the trip back to Earth. But they did get it shut, and they've been opening it and making great strides, and they're looking at it. And if you look up asteroid Bennu, Bennu, I think, if you look up asteroid Bennu, then you'll find all sorts of things. So Bennu apparently is just bits and pieces that kind of clump together, probably from other collisions in the asteroid belt.
Oh, wow.
Right? So it may have a bigger core somewhere, but a lot of the stuff on top is just like pea gravel.
Wow.
It's just like pea gravel in extraordinarily low gravity. If you or I were there, a marshmallow on Earth would outweigh us.
Wow, that's interesting.
Yeah, so makes it almost impossible to navigate over the surface. You can fly over the surface, but in no way could you walk over the surface. It wouldn't be, there's not enough gravity for friction for any kind of an astronaut or a robot or anything to walk over the surface, so kind of interesting. But this accretion process, planets grow by collision. There wasn't really much evidence up until about 1992 because we'd never seen an impact like this. We'd never seen, we see meteors hit the Earth. We see a lot of us go out for meteor showers. Have you been out to see like the Leonids or the Perseids in August is like one of the real favorites because the weather's nice. And actually coming up over the next week, you should be able to see the Orionids. They peak around Halloween. So there's more meteors in the sky now, friends. And they said, oh, well, little teeny rocks and they fall. And how much mass does the Earth gain a day? About 10 metric tons. But compared to the mass of the Earth, that's a drop in the ocean. It's really not anything much at all. And 1992, something amazing happened. Gene Shoemaker, again, same guy, now much older, and his protege and partner, David Levy, and his wife, Caroline Shoemaker, they were all looking at exposures and they were looking for comets. And in fact, they found a comet that was like nothing anyone had ever seen. They were able to resolve 26 separate comets, all in a train, traveling together. Do you remember this story?
I do, very vividly.
Yes, indeed. And wasn't it stunning?
It was.
I mean, everybody was looking at it saying, what the heck? Why do you have comets playing follow the leader? It puzzled everyone. And Levy and Shoemaker and other astronomers said, well, you know what probably happened? Here's a comet that flew too close to Jupiter. Too close to Jupiter. And it turns out that if you fly too close to a very large planet, the gravity field can tear you to pieces. Have you heard about where black holes, if you fall into one, you get stretched out and torn apart?
Spaghettification.
Very good, very good. Yes, indeed, spaghettification. It happens with moons and comets too, and it's called the Roche effect for Edouard Roche, who was a French 18th century astronomer. And he basically calculated that if you have a body, I'm going to use my pen again, let's take our table as being planet Jupiter, the gravity down here close to Jupiter is considerably stronger than the gravity at the far side. And if it's strong enough, it can actually tear a moon apart. The closest you can get a moon to a planet is called the Roche limit. And if you look back through the How Do You Know catalog, you can find episodes on that too. And if you really would like, you're welcome to email me at astronomyforeducators@gmail.com or Dr. B at explorescientific.com. And I will send you a program list with links. And you can look these things up. Really very fascinating. Well, Comet Shoemaker-Levy 9 passed inside Jupiter's Roche limit. Mm-hmm. And so it was torn to pieces, but obviously it's traveling 30,000 kilometers an hour. So it didn't get captured by Jupiter, but the bits got torn apart, all traveling on the same path. And so you had this 26 major fragments, who knows how many little pieces. And it was watched very carefully. What's its orbit going to be? It was falling in toward the inner solar system. They realized, it's going to come back and collide with Jupiter. And today, as we understand solar system dynamics, we think that big planets, Jupiter, Saturn, Uranus, Neptune, but particularly Jupiter, and the smaller planets less or so, they protect the inner solar system, because when things go by, they either capture them or rip them to pieces. And when they tear them apart, statistically, it's very likely they're going to make one trip around the sun, bang, collide with the original planet again. No more meteor threat. No need for Bruce Willis or his team of adventurers to go up and plant a nuclear bomb. So these big outer worlds protect us. And indeed, 1994, I remember, do you remember watching it?
I did. I watched the whole thing.
And the impacts were on the backside. Our Galileo spacecraft captured that. But we were all watching for the impact scars. Can we see them? They were enormous.
Oh, yes.
Enormous. The impact scars were larger than the Earth. They were huge. And they took, I was able to track them for more than a year with an 8-inch telescope at home, and professionals were able to track them for almost 2.5 years before these impact scars finally faded out. You realize that any one of those cometary fragments would have been a dinosaur killer type impact.
Oh, yeah.
It would have, if it hit the Earth, it would have, not to mention 26 in a row, but one of them would have, it would have been a huge extinction level event. Whether or not people survive, which is very doubtful. Big mammals don't do well in asteroid impacts. But civilization would have certainly been destroyed, even with the smallest of them. And so we get this traumatic event. And do you remember the Chelyabinsk meteor in Russia in 2013?
Yes, of course. I saw that as well.
And I was very thrilled. I'm like, everybody in Russia must have a dash cam, but that's what almost all the video was dash cam video.
Yeah, you're
and
right.
security photo video. And I remember there was a short video clip. It was black and white. Two people chatting in Russian, no idea what they were saying, but they were looking out the window and going, "Ooh, look! It's a big meteor, or something. There's a big smoke trail in the sky." And then the shockwave hits, blows the window out, knocks them down. I understand those people were not seriously injured. Destroyed some buildings, thousands of minor injuries, mostly from people standing next to windows and going, "Ooh, look!"
Yeah.
When the shockwave hit, and when that happened. That whole day, I told my science classes, I was teaching high school physics, astronomy at the time, and I said, no, we're all watching this. As new video came in during the day, I said, we're all watching this. And they're like, why? What is it? And I said, well, this was a 0.5 megaton explosion, 500 kilotons.
Oh, I didn't know that.
Hiroshima, 15 kilotons.
Oh, okay.
So
That's significant.
15 cents to a $5 bill. Yeah, this was boom, baby.
Oh, my.
The only saving grace is it detonated about 45 miles up, about almost 60 kilometers up in the atmosphere. And at that speed, 30 to 40,000 kilometers an hour, what happens, you're compressing the air in front of the meteor. Oh. It reaches the density of steel. It literally is like hitting a wall. Have you heard that if you jump into the water from too high, it's like landing on concrete because the water's just incompressible?
Yes.
And get enough speed, enough kinetic energy, air acts the same way. Oh. And we think of, oh, I can wave my hand. Oh, it's a big wind. Look, I lost a limb off a tree. There's, but no, if you get to like 30,000 kilometers an hour, yeah, it's like hitting a steel wall. And it heats up the vibration. It just, boom, it detonates. And Chelyabinsk was, my student said, well, what would you do if you saw the big meteor? I said, well, I would go outside and I would probably, tape my phone to a brick wall and sit there in a chair with some goggles and hope I would be like the Memorex man and see my tie flying behind me as the shockwave hit. They said, what if you were hurt? And I said, what did Shakespeare say? This story the good man will tell his son, and upon Crispin's day, each man who is here with the king shall strip his sleeves and show his scars and say, this I had from the huge meteor. Not quite, but you get the idea. I would have been proud to have those scars. That would have been awesome. They all thought I was nuts.
You wouldn't have there would be no talking about it.
Yeah, I would have had to wear earplugs and it might not have helped.
Just to liquefy your internal organs.
It's a risk I would have been willing to take. For science!
Yeah.
Stand back, I'm about to try science. The other big impact, and this story came out in 2021, the ancient city of Tel al-Hammam. It's in southern Syria. Did you hear about this one?
You can refresh me.
The archaeologists, it's a Bronze Age city. It was destroyed about 3,500 years ago. And they found this 5 meters, so 30-foot deep layer. That's just all jumbled, charred, broken bits. No skeletal remains bigger than a centimeter, so nothing bigger than your fingernail. And they said, wow, melted pottery, melted bricks, bronze tools and weapons that just melted and ran like ice cream on a hot day. And they realized, gee, the temperatures had to be about 5,000 centigrade, which no one in 3,500 BC could produce anything like that. They were indeed forging bronze and alloys of copper and tin, and they were working gold. They didn't have steel technology. They couldn't smelt iron, and yet here were these huge temperatures. And what happened? This was an asteroid impact or a comet fragment. We're not sure, but it totally obliterated the city. It would have been the classical biblical pillar of fire. The archaeologists suspect that this was the origin of the legend of Sodom. And indeed, the shockwave, just like the impact at Meteor Crater, would have gone out radially. 40 kilometers away, a city which was biblical era Jordan had its walls knocked down by the shockwave.
Oh, wow.
And it was close to the Red Sea, and of course you get this huge mushroom cloud from a lot of heat energy going straight up. It would have sucked up cubic kilometers of water out of the Red Sea and deposited it. It salted the earth so badly there was no agriculture there for 6 centuries.
Oh, wow, that's significant.
So you want to talk about the finger of God goes, city gone, destroyed. It would have been quite the horrible impact event. No one survived. Within probably 100 or 200, certainly within 50 to 100 kilometers, nothing survived. So where does this lead us today? There was this story just came out a few days ago. Astronomers have finally seen, witnessed, and found evidence for a direct planet-to-planet collision. The star had a huge, long alphanumeric character name from the Gaia catalog and the Hubble catalog. But of course, since it was now interesting, they gave it a new name, Assassin 21QJ, which they're changing James Bond. You know, it's going to be Assassin 21. So anyway, they've named this star. We have telescope systems, and what they do is they survey the skies and they look for changes in brightness. Mm-hmm. Because what they're really looking for, can you guess what they're looking for? If they're looking for stars that brighten significantly very suddenly?
Yes.
It would be?
Like a pulsar or a
supernova.
A supernova. Yes,
Supernova explosion, right?
course.
So they're looking for, indeed, they do detect pulsars. But what they're really looking for is novae. Small kilonova, big supernova, because you only get a few per century per galaxy, so you have to watch a lot of galaxies very carefully to see them. This star didn't get bright, it got dim. You may remember all the falderall a couple of years ago, 2019, when Betelgeuse got a lot dimmer.
Yes.
And people thought it was going to explode. And we were all like, yay, yay, cheering for the death of a star. What's wrong with us? I don't know. But
It was a good movie, Dr. Mark.
it was a good movie. I'm sure at the time there were dinosaurs rooting for the meteor. It's just the way life is. But what happened here, whenever they see a change in brightness, what scientists automatically do, and it's not the guy who's the principal, the gal who's the principal investigator, it's not the chief scientist who does this. He goes to his flunkies, right? He goes to his lab assistants, his graduate students, and he says, okay, go back and search the records and see what this star looked like, see if we can see. Because if we're seeing it change now, what did it look like before it changed? Well, this star not only gets dim, they went back and checked the records in an infrared telescope, and they found out that about 2.5 years earlier, it had gotten really bright in the infrared. It had gotten really hot. But the heat signature was not quite perfectly aligned with the star. And so could it be a protostar kicking off fusion? It's going to be a binary system. There was lots of speculation. But they realized this cloud of dust that had caused the star to dim, it would have had to have been heated up over 1,000 degrees centigrade. Wow, about 17 to 1800 Fahrenheit. So it would have had to, and they it would have had to be really, really close if it was going to get, because Assassin 21 QJ is a sun-like star. It's a small dwarf star. So it's not one of these huge, energetic blue giants or red giant. It's a relatively small, calm, normal, average star. Okay. And so, if it was that close, in 2.5 years, we should have seen it eclipse the star many times, because it would have an orbit like Mercury, maybe 40, 80, 100 days, right? It would have been a very...
Yeah.
But it was 2.5 years between these two events. Well, what orbits our solar system in 2 years? Mars does. And so they had a couple lines of evidence, and they said, well, whatever this was, it occurred between 2 and 16 AU. That would put it somewhere between the orbit of Mars and Uranus. Or maybe, then you're like, wow, what's going on here? Well, they looked at the IR signature and they realized, if it's giving off this much light at this temperature, you can compute how big it is. 750 times the size of the Earth.
Oh, that's
Whoa. Yeah. Our sun is about 100. It's some, that's much bigger than our sun compared to Earth. And this star isn't that big.
Wow.
So people are scratching their heads and saying, it's not anything like we saw. Well, we start to get converging lines of evidence. And this is exactly what the How Do You Know program is about. How do we know these things? Oftentimes, we get converging lines of evidence, different types of research with different equipment, different experimental techniques, but they both intersect at the same point, which gives us confirmation that we've got real data. And it was the Wide Field Infrared Survey Explorer, WISE. NASA loves acronyms. I think all astronomers love acronyms. Yeah, I don't know what Assassin stands for. I'm sure it's something.
You're probably right.
And I want to be at the, guys, if you're a professional astronomer, I would love to be at the party where you come up with these names, because I'm sure it's a hoot. It's got to be a riot. So we get this idea that we've got this something, and it generated this huge cloud of dust, and it got really hot, and it took a while to dim away, and the light bulb goes on. It was two planets colliding together. Two planets, and they ran the models. Now the really sharp folks with the computers. And this is, I bow to your mad skills, folks. You science, you computer modelers out there who do this stuff, I am always in awe of the skill and that they display. But they were looking at this and they said, okay, let's model this and let's see what we come up with. And the impact energy, they said, two planets about half the size of Neptune. So either super Earths or ice giants. And an ice giant is an Earth-like core or bigger that attracts in big enough to attract. If you get big enough, you can hold gases like methane, hydrogen, helium. Then you can start to build a gas giant type atmosphere. And these ice giants, they're not super huge like Jupiter, but they're collecting all these gases which get compressed into solid form because of gravity. And so we're looking at, two planets about 7 Earth masses apiece
Impressive.
colliding. And they don't think it was a gentle bump from behind parking lot fender bender. They think it was more of a head-on, airbags deployed smash.
Oh my goodness. Okay.
And the crazy stuff is, if you have 2 planets that are, say, 6 to 8 Earth masses, do you know what the impact energy works out? It's stupid. I'm going to write the number here for you. And
10 to the 34th power.
yes, 10 to the 34th power joules. How much? I looked at that number and I'm like, this is ridiculous. 10 to the 34th power. You just don't come across. I'm an astronomer and an astronomy and physics educator. You just don't come across numbers like that very often. 10 to the 34th joules. And so I started Googling, and I'm like, how much energy is this? So I looked up, and I'm like, gee, how much energy does the sun put out in joules? And you can Google that for yourself, friends. And I got a fairly impressive number, and then I divided it into 10 to the 34th. And they measure the sun's output in joules per second. So I got this enormous number, but 10 to the 34th is even more enormous. It's as much energy as the sun puts out. Not just how much falls on us, but the entire sun in 8.25 years. It's like 8.2 something years of energy from the entire radiative energy of the sun in all the frequencies from gamma to infrared. It's just,
That's a jaw drop.
it's an insane amount of energy. There's a link. If you go to if you download today's program notes, there's a link in the show notes there. The sharp folks with the computers, they modeled this. The 2 planets come together, and it wasn't quite enough energy to be a dead center head-on collision. That's like flipping a coin and having it land on edge. That really doesn't happen very much. So they modeled what they call a glancing blow collision. And maybe you've seen these, crash dummies where the cars come together and they don't quite hit head on. Mm-hmm. Same thing. It basically, the 2 planets went past each other, ripped off they released an enormous amount of material. They went past each other, and then the real horror show is the cores come back and recollide and merge about a year later.
Oh.
I know.
No. Wow.
Yeah. Imagine a glancing head-on with your car, and then the pieces are sucked back in and smashed together, finishing the destruction of whatever was left.
Oh, man.
They think that about 99% of the mass of both planets is now incorporated into one new planet. And they actually have used telescopes, and I'm waiting for Webb. I'm waiting for the Webb telescope because it's infrared. This is perfect job, James Webb. Go Webb telescope. But they have imaged the new planet. It's got a surface temperature now of around 1,000 Celsius. It's enormously hot. It's obviously all of the ices that were compressed and solidified. This planet's atmosphere has blown up. All these gases have boiled, but it gravitationally is too big for them to fling out and be lost.
Oh.
So they lost 1% of their mass, but considering that would have been about 16 Earth masses, 1% is a substantial chunk, right? A lot of this is in dust, and we look at this and we say, oh, well, if Uranus has its axis tipped 95 degrees, right? If Venus has its axis tipped 185 degrees. So these collisions in early solar systems, it's a violent place.
Yeah.
It's not just peaceful planets. No, planets are formed in collisions, in violence, in thunder and lightning and destruction unimaginable. Unimaginable. And the other thing to think about, oh, well, this is 16 AU out. If I was in a peaceful Earth planet 1 AU away from the sun, I would be far away, right? It would be 16 Earth orbital radii away. It's not going to be a good day for a long, long time.
Uh-huh.
Where do all those pieces fall? Into the inner solar, right? The sun is the biggest gravity well. Their star is the biggest gravity well there. And we know that our solar system experienced what we called the heavy bombardment period, the Noachian age, where the sky must have been filled with hundreds of comets. And things like the Chelyabinsk meteor would have been the little firecrackers compared to the big, big booms. And the other thing, this ice giant, a lot of the pieces falling in will be cometary, right? They'll cool off, they'll solidify. People have said for years, oh, I bet Earth didn't form with water because Earth is a silicon-type terrestrial planet, right? It's mostly iron and silica and aluminum and rock and metal. And it condensed at very high temperatures. How did it get water? Water wouldn't have been able to stay. Oh, well, water was brought in by comets and asteroids. And we're now seeing how that process works.
Oh, wow.
And you think, oh, the Earth's oceans with kilometer-sized chunks of water and methane and carbon dioxide frozen into a cometary ball, smashing into the Earth, providing it with both atmosphere and oceanic. Yeah, early solar systems are not the vacation destination you would want to pick if you had a time machine and a spaceship. You just
Right.
you would. It's kind of like if you had a time machine, would you go back to 2020? No.
No.
No. Every time machine in the world, 3600, the instruction manual says, do not set for 2020. Bad day, right? Early solar systems would not be the happy place to be. They would just be spectacularly dangerous and high impact environments.
Yeah.
Creating solar systems is messy and dangerous and violent. And the thing that I love about this research is that it shows us just how thunderously powerful these type of events are. I remember one of my professors telling me, well, how powerful is a supernova? If we made the Earth out of TNT and lit it off with a fuse like in a Bugs Bunny cartoon, no, that wouldn't do it. What if we had the mass of a sun? No, that wouldn't do it. It's still millions and billions of times more energetic than that. The death of a star is so stunningly violent, but the formation of planets, which I thought about accretion theory when I learned about it in the 90s, and I was teaching astronomy at the time, and I'm thinking, oh, here's a planet, and here's little cometary pieces, and whack, 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 and okay. No. It's much more nutty than that. Much more crazy. In fact, there's other research in the news, and this is in the show notes as well. Why on earth does Earth have metals near the surface? If you think about this, if the Earth was whacked by a planet called Theia, the size of Mars, and it made the moon, and it would have, like this collision, reliquefied the entire surface, why didn't all the metals sink to the core? Why do we have things like iron and tin, gold, and all the others in our crust? It turns out the computer folks now say that when you get a big asteroid impact, like the dinosaur killer impact, okay? The Chicxulub impact. You get a 10 to 20 kilometer asteroid that strikes the Earth. What happens is it makes basically a magma ocean. And the bottom of that ocean is colder, but the ocean is full of convection currents, and it keeps the metals from sinking to the core. It
Okay.
traps them in the upper lithosphere. So this whole process, destructive, yes, but you think about biology, plant, animal, human, there's all sorts of minerals that are essential for life,
Yeah.
right? Lots of us take vitamin and mineral supplements. Lots of us, our doctor says, we're getting older, you need more calcium. Oh, have you tried magnesium, zinc, one a day with, 36 dozen vitamins and minerals in one handy tablet? And you look at this stuff, why do I have to have all these minerals? Our biology, our enzymatic biology lets us be alive at room temperature, conduct chemical reactions at temperatures that don't fry us like a steak. Well, those all depend on enzymes, which are almost all of them based on metals.
Interesting. Wow.
Yeah.
That's an eye-opener.
So these kind of impacts, this whole accretion business, as violent and ferocious as it is marvelously tuned to. It's marvelous how these impacts produce planets which are suitable for living organisms. Saying nothing about intelligent life. The news the last couple of weeks have made me skeptical, but certainly biological life of all kinds, plant, fungi, bacterial, animal, depends. We could not be here if we did not have these violent accretion type impacts.
Yeah. Yeah. From chaos comes order.
Indeed. Producer Paul, did we get any fun questions today?
Would the Milky Way probably hold more gas planets than rock planets?
Wow. We are only in the last few years have we got technology where we can start seeing rocky planets. Most of those are super Earth size. So I would say right now, we don't have enough data to answer that. My intuition says smaller things are more numerous than larger things. That tends to be the case with all life, physical features, craters, mountains. Little hills are more prolifically sprinkled about than great mountains, and small craters are far outnumber big ones. So if I had to put a bet on the roulette wheel of science, I would say when we've got a really good sample of planets from, say, 200 light years out, we would find that rocky planets probably outnumber gaseous giants 2-3 to 1. And it gets down to the ugly, vexed question, what is a planet? I'm going to do a documentary. Pluto is a planet, by the way. I will die on that hill. Pluto is a world. And my definition for planet that I taught for years, I used to tease my students and ask them to go look it up because it wasn't in the astronomy books. Because it's an ancient term. And it didn't have a modern scientific definition until 2006 when they mucked it up. But planets are, by nature, what they are. If you're big enough to crush yourself into a sphere, you're a planet. Nature decides, right? It's not about, you're too far away or you're too small to ride this roller coaster. It's, are you big enough to crush yourself into a sphere with your own gravity? Then you're a planet. Pluto qualifies. Things like Makemake does not, because it's shaped like a football. It's clearly not big enough to compress itself into a sphere. If it's shaped like a turnip or a potato, it's not a planet. But we know that there's lots of planetary-size objects. Do you have any others? Any other fun ones?
No questions. John Ray says he's going to donate the book once he's done studying it.
That's outstanding, John. You're a scholar and a gentleman, and thank you for sharing your copy of Star Mentor. Any questions, Chris? Anything that struck you? Any comments?
Well, there's a lot of things that I learned that I didn't know that you already just explained. It was amazing about the the collision of the newest collision that we were talking about?
Yeah.
Where is that?
The Star Assassin 21 is about 1,800 light years away. And we
Okay.
think of that as I want to get in a ship and go there distance is very, very far away. But in terms of our galaxy at a couple 100,000 light years across, 1,800 is kind of like in our local area.
Oh, okay.
It's in terms of a galaxy, it's not terribly far away.
It's in our neighborhood.
It's in our neighborhood. That's right. That's right. It's like somebody who lives across town.
Yeah, and stars, I guess. Yeah.
Yeah. So you really kind of have to recalibrate your distance and mass and energy meters when you start talking about these events. The shock absorbers on your brain just bottom out. It's
Yeah.
it's just fun. So, did you have a good time today?
Yes, this is very fun.
Awfully glad you came on, and this was impromptu, folks. Chris came in, and a couple weeks ago I was helping him with his telescope, and he came back to say, and it's working now.
Yes, it is.
It's working, and he's happy with that. And we gave him a couple lessons on how to collimate and use his new telescope, and he went away a happy man and came back to say thanks. And I said, hey, it's time for the How Do You Know show about being a guest. And he very nicely said yes.
Thank
And
you.
I'm very thrilled to have you here. And friends, that's it for this
Don't
week.
forget your book.
Yes, indeed. The Star Mentor book. Chris owns one. He highly recommends it. So do I, but I wrote it. So there you go. If you're considering a telescope for someone, for yourself, or for someone else this holiday season, don't fail to pick up a copy of Star Mentor. It's very easy to read, and it's like having an astronomy instructor right there with you. And the biggest problem, those of us who are astronomy enthusiasts, we see is somebody gets a telescope and they go, okay, I've seen the moon. There's the moons of Jupiter. Now what do I do? And because they lack guidance, because they don't have the knowledge to bring to the eyepiece, they lose interest because they're not getting enough out, because they're not bringing enough in. Star Mentor is a book full of more than 50 exercises and 185 illustrations and drawings, and all the drawings are mine. So if you like them, if you don't, well, my fault. But this is basically my observational astronomy course, which I taught for more than 40 years, boiled down into a very friendly conversational format for you. It's family friendly, it's child friendly, it's adult friendly. And a lot of times, people say, gee, a 12-year-old could do that if only you had a 12-year-old when you needed one, like a Leatherman tool. But this is designed to be readable by everyone. If you're an advanced amateur and people are asking you, how do I know? How do I do this? And you're kind of frustrated because you know what you know, but teaching what you know is a different way. It's a different skill set. This book will help you learn to teach others and share your hobby and love of astronomy with them. It's available on Amazon, fine bookstores everywhere, published by Springer, part of the Patrick Moore Practical Astronomy series. We're very honored to be part of that, and we hope you'll pick up a copy. Next week, we'll be back with another exciting episode of How Do You Know, and we hope you'll tune in. Thank you, everybody. I'm Dr. Daniel Barth, and my guest, Chris
Volmar.
Volmar. I'm bad with names. It's a terrible handicap for a teacher. We'll see you next week, everybody. Thank you.
Thank you.